Hello students, hope you all are doing great, enjoying your days, but in between you should study and find out some time for all subjects, and especially science is very important subject, and you know that we are going to study motion, and this is part 4, and this chapter is basically a chapter which comes under physics. Right, and you have learnt about so many topics in this chapter. There are few more topics we need to do, so we are going to do a few more topics, and those topics are important symbols, which you have already done in previous videos, but it is a sort of revision for you. Now, equations of motion, examples of uniformly accelerated motion along a straight line, derivation of first equation of motion by graphical method, derivation of second equation of motion by graphical method, and derivation of third equation of motion by graphical method. We are going to derive the three equations of motion one by one by using graphical method. Now, let us see the important symbols. Small u stands for initial velocity, small v stands for final velocity, small s is for distance covered or displacement, small a is for acceleration, and small t is for time taken. I hope you remember these symbols well. If you don't remember, you are suggested to revise these symbols. These are very simple, and unless you know these symbols, you won't be able to solve the problems, especially the numericals. Now, equations of motion. What are equations of motion? When an object moves along a straight line with uniform acceleration, it is possible to relate its velocity, acceleration during motion, and a distance covered by it in a certain time interval by a set of equations which are known as equations of motion. And there are three such equations of motion. First one is V equals to U plus AT. Second is S equals to UT plus half AT square. Third one is 2AS equals to V square minus U square. Students, I hope you must have noticed that in each equation there are four different symbols. Like in first equation, final velocity v, then initial velocity, then acceleration, and then time. So what is the use of these equations? Mainly these equations are used for finding the unknown quantity with the help of three known quantities. For example, like if you know about the initial velocity of the object, acceleration of the object, and the time taken by the object to cover a certain distance, then you can find out that with what final velocity the object is moving. In second one, like you can see S equals to UT plus half AT square. If you know any three of these, suppose you are aware of the displacement or the distance covered, you are aware of initial velocity, you are aware of acceleration, you can easily find out time. And now in the same manner, the third one is again very important. If you know about acceleration, if you know about distance covered, you can find out final velocity if initial velocity is also known to you. Means if you know a, s and value of a small u, you can also find out final velocity v. So all these three equations are of great help for us whenever we are solving some numerical problems. Next thing is examples of uniformly accelerated straight line motion. There are so many examples in our daily life. Let us see two examples from our daily life. Like you can see in the first picture, like a freely falling object is shown. An object is falling freely due to the gravity of the earth or due to the effect of gravity of earth. So this is an example of uniformly accelerated straight line motion. It is a downward movement or the downward motion. And in the second picture, you can see there is a car moving along the straight line and it is uniformly accelerated. Uniformly accelerated means, as we have learnt in the previous lessons that or the previous videos, uniformly accelerated means that when an object changes its velocity, and every time there is equal change in velocity with equal intervals of time, means there is equal, either there is equal increase in velocity or there is equal decrease in velocity with time, then it is known as uniformly accelerated motion. Next thing is the derivation of first equation of motion, which is also known as velocity time relation. You can see this graph. You are suggested to draw this graph in your notebook and practice this. And this graph is very important because the same graph we are going to use to derive first equation of motion, second equation of motion and third equation of motion. Derive means, or derivation means, we want to know, or we are going to find out from where, or you can say how these equations have come. Right. So the next thing we are going to do, that we are going to find out the first equation of motion. See this graph once again. Now we are going to start with the derivation of first equation of motion. And we should keep these things in our mind. These points are very important. First point is, object is moving along a straight line under uniform acceleration. Please note that these equations of motion are applicable only and only for an object which is moving along a straight line and under uniform acceleration. Initial velocity is u, and like you can see from the graph, u is not 0. Okay, u is not equal to 0. It is having some other value other than 0. The object acquires final velocity small v in time t. The velocity changes at a uniform rate small a. Initial velocity equals to OA, which is equals to CD and which is equals to small u. You can see in the graph OA equals to CD, which is equals to small u. Please see, this pink line is our main graph. And these dotted lines, like you can see, line BC is a dotted line, which is a line drawn by us and which is perpendicular to the time axis, or you can say the x-axis. And there is another dotted line BE, which is drawn perpendicular to the velocity axis, or you can say y-axis. And we have drawn another line AD, which is again parallel to the time axis. Okay, so this line BC is perpendicular to the time axis. The line AD and BE, these are perpendicular to the velocity axis or the y-axis. Right? Next thing, final velocity is given by BC. BC equals to small v. Means finally the velocity of the object reaches to this particular point, and here the value comes to small v. And the time interval during the journey of the object is OC, which is taken as small t. Now, from the velocity time graph, acceleration equals to change in velocity upon time taken. You have learned that acceleration is the rate of change of velocity. So, the formula of acceleration is change in velocity divided by time taken. And acceleration equals to BC minus CD divided by AD. A equals to BD by OC. A equals to V minus U by T, or AT equals to V minus U, or v equals to u plus at, which is the required first equation of motion. And here comes the graph once again. Now I think it is easy to understand for you. See, acceleration is change in velocity upon time taken. So change means final minus initial. So final velocity is BC, that is V, right? We have written here V. And the initial velocity, it was CD. So this is the value small u. This is having the value small u. So in place of change in velocity, we are writing v minus u, which is also showing this particular portion bd divided by time taken. Time is equals to OC. OC is also equals to AD. You can see these two are parallel lines. They are equal and it is equals to the time taken. So A equals to V minus U upon T. Or you can solve like you are solving linear equations. So by cross multiplying you get AT equals to V minus U, or by transposing you get v equals to u plus at. So this is the required first equation of motion, which is very important part of this chapter. This equation is the very first equation, which is also known as velocity time relation. Okay, so you should know another name of this first equation of motion, that is velocity time relation. Right, now it's time to move to the next equation of motion. We are going to learn how to derive the second equation of motion. Second equation of motion is also known as position time relation, and as I have already told you that we are going to use the same graph for all the three equations. This part of the graph AB, the pink line, is the main graph, and you can see that on x-axis we have taken time and on y-axis we have taken velocity. Let us see the derivation. Here, we consider that the object has traveled a distance s in time t under uniform acceleration small a. Very important to note once again that these equations of motion are only and only applicable for straight line motion, and that should be a uniformly accelerated motion. Next thing, distance traveled by an object equals to area covered under velocity time graph. Distance covered by an object is equal to area covered under VT graph, which you have already learnt in previous videos. If you remember, we have learnt in previous video and it can be seen in this graph also. This is the area covered under the VT graph. You can see I am trying to shade this particular area we are talking about. If you find out the area of this particular region which is covered under the main VT graph, that gives you the distance traveled by an object. Right? Now, let us move to the next slide and learn how to derive this particular equation. From the VT graph, distance travelled by the object is given by small s. This is a symbol of distance travelled. Then, as we have learnt earlier, that area covered under VT graph equals to the distance covered. Then you must have noticed in the graph that the area of the shape which was shaded, the shape is basically a trapezium. Let me show you the graph once again. Like here you can see this shape OABC. Does it look like a trapezium? Yes, it is a trapezium because it has one set of parallel sides. Which are the parallel sides? OA and BC. Right? So it is a trapezium. And can you divide this trapezium in two different shapes like rectangle and triangle? Yes, it is very much clear from the figure. So you can see OADC, it is a rectangle, and ADB is a triangle. Right. So area of rectangle is area of rectangle is length into breadth or breadth into length, and area of triangle is half into base into height. So we have written for area of rectangle OADC, OA into CD. OA into CD plus half into base. AD is the base of this triangle and BD is the height of this triangle. Now let us substitute the values. OA equals to small u, OC equals to AD equals to T. OC and AD both are equal and they are equal to the time interval small t, and BD equals to V minus U. This particular part we are talking about, that BD equals to this one, BD, this equals to V minus U, which is also equals to A T. Right? You have learnt in first equation of motion. So, after substituting the values, S equals to U multiplied by T plus half multiplied by T multiplied by AT. So, finally, it gives you S equals to UT plus half AT square. Right? So, this is the required second equation of motion, which is again very important. Please note down in a notebook and practice these derivations. Okay, you need to practice these derivations several times so that you can solve them very easily in exam, because it is a very common question. Mostly one of these three equations is usually asked in your exam, so practice them without any fail. Let us move to the last equation of motion, that is the third equation of motion. We are going to derive the third equation of motion, which is also known as position-velocity relation. Again, the same graph. You have velocity time graph once again, which is for the uniformly accelerated motion. Okay, and here comes the graph once again, and we consider that an object has traveled the distance s in time t moving under uniform acceleration small a, and distance traveled by the object is equal to area covered under Vt graph. Same thing we are going to do once again, that is we want to say that the area covered under the Vt graph is equals to the distance traveled by the object. So we need to calculate this area at first, right? And this is basically a shape of a trapezium. Let us see how to solve it. From the Vt graph, distance traveled by the object is s, and s equals to area covered under Vt graph, you have learnt earlier, and s equals to area of the trapezium OABC. S equals to half into sum of parallel sides into height, and S equals to half into OA plus BC into OC. S equals to half into U plus V multiplied by T. But from first equation of motion, T equals to V minus U upon A. So we will replace the value of small t here, and we get half into V plus U into V minus U divided by A, or 2AS equals to V square minus U square. Let us see the graph once again and try to understand this derivation. Okay, like you can see, this is the shape of a trapezium OABC, right? Now you need to calculate the distance covered. So distance covered equals to area of trapezium OABC, and formula of area of trapezium is half into sum of parallel sides into height. So you need to see this figure carefully, students. If you are not able to find this particular shape as a trapezium, then you can do one thing. You can simply rotate this picture, and you can definitely find that it is basically a trapezium, right? Because there is only one pair of parallel sides, right? So you can see that we are using half into OA plus BC. Okay, half into OA plus BC. OA and BC are the parallel sides, multiplied by OC, which is the height of the trapezium. So let us replace these values. S equals to half into U plus V multiplied by T. And now you know that T equals to, you have learnt in first equation of motion, V equals to U plus AT. So now from the same equation, can you write T equals to V minus U by A? Yes, you can. So let us replace the value of a small t. T equals to V minus U by A, and here we have replaced this value. And you know, actually these all are combination of concepts of physics, maths and geometry. All the three subjects are merged here, and you are solving so many things together. You can see it is A plus B, A minus B. This is an algebraic identity, right? So V plus U into V minus U. So by the algebraic identity, you can write V square minus U square. So here comes the final equation, 2AS equals to V square minus U square. Okay, so here the finally you have got the third equation of motion, 2AS equals to V square minus U square. This is the third equation of motion, which is again very important. If you know any three values out of these four, so there are four different symbols, A, S, V and U. So out of these four, if you know any three, you can easily find out the fourth one, which is unknown. Right. So all the three equations are very important, and you can say this topic is the heart of the chapter. Next time we will try to solve, and we will learn to solve the numerical problems based on the equations of motion. Till then, you all are advised to revise all these equations of motion in your notebook, practice them and try to understand them. And unless you write in a notebook, it is difficult to learn them, right? And as I have already told you that one of these equations usually comes in exam, so without any fail, please practice them. Please like and share this video and subscribe my channel. Stay healthy, stay tuned. Thank you.